Awesome. So, like Fletch said, we're going to be talking about cross-cutting concerns, addressing cross-cutting concerns in ASP.NET Core today. Just real briefly, so you know who you're hearing from, my name's Floyd May. I run this company, Canyon Trail. Check us out at canyon-trail.com. You can hit me up on Twitter at @SoftwareFloyd. If there's a particular slide or a moment in the presentation today that you think was just awesome, I'd love for you to tweet at me. Blog is at medium.com/@floyd.may. So we're talking about cross-cutting concerns today, and I think the first thing that probably should be crossing your mind, pardon the pun, about that is, well, what the heck is a cross-cutting concern? I know when I've used this term in the past, I know Fletch, you and I sort of chatted about this in Slack briefly. This is a phrase that not everybody is familiar with, so we need to maybe spend a little bit of time talking about what is a cross-cutting concern. So let's say we are responsible for some sort of standard e-commerce type app. And so you've got a catalog browse, catalog search type stuff. So you're trying to find the product that you want to eventually buy. Okay. You got some order management. We're going to add some stuff to the cart. We're going to check out. We're going to do our payment information, pick what kind of shipping, pick where we're going to ship it, that sort of thing. We've got some fulfillment, people working at a warehouse, picking stuff off of shelves, packing it up into boxes, sending it on to the customers. Inventory management, making sure that we've got all the stuff that we're supposed to have in the right amount so that we can keep up with the demand, so on, so on, so on. So this idea of a cross-cutting concern is you have something like, say, authentication that cuts across all of these areas of this application. To maybe put a little bit finer, well, first off, sometimes cross-cutting doesn't necessarily mean every area. Sometimes it means just a bunch of areas. So, for instance, e-commerce, maybe we don't need to log in to be able to browse the catalog. That's kind of nice because then we can, do fun things like show up in Google searches and whatnot. Now, to get a little bit more specific, what if instead of thinking of functional areas, maybe we're going to think about specific HTTP endpoints. So we've got an endpoint that's at this particular URL, another one, and so on and so on. So we have a cross-cutting concern that touches all but these two HTTP endpoints. So the idea behind a cross-cutting concern is this. It's something that needs to be handled exactly the same across a broad portion of an app. So regardless of what kind of, functionality is represented by some particular area of an application or a specific endpoint, a cross-cutting concern is something that needs to apply to that one specific area exactly the same as it's applied to another one, to another one, to another one, to another one, so on and so on throughout the app. So let's talk about some examples of cross-cutting concerns. So authentication, this one's a great one. This is like a key example for cross-cutting concerns. Authentication being who are you? Authorization, very similar, but not exactly the same. What are you allowed to do? Logging, this is something that's, really, really useful to be able to just, every time you touch this particular area of the application, it gets logged and this particular type of information gets logged. Now, if you notice, I have protocol compliance crossed out here, and instead I have translating to HTTP status codes. And the reason I did this on purpose because I was going to say protocol compliance and then just explain it, but I figured putting this text here would be better because we're dealing with web apps. Web apps speak in HTTP. HTTP is a protocol, and that protocol has rules. So for instance, if somebody's trying to access something that doesn't exist, the protocol dictates you should respond with a 404, so on and so forth. We're going to see some examples of this here in a little bit. Timing, let's say we want to time how long particular operations take. Caching, some things may be cacheable where we want an HTTP proxy that's upstream from us to be able to cache the results of those things. Transaction management, this is another great example of a cross-cutting concern where, say at the beginning of an HTTP request, we want to open a database transaction, and at the end, if it succeeds, we want to commit the transaction. If we have something go wrong, an exception gets thrown, we want to roll back that transaction. This is a great example of a cross-cutting concern. Now, if you think about cross-cutting concerns, it's not uncommon, and I know I've seen web apps done like this before. I've written them long, long ago like this before, where you have a little bit of innocent-looking code like this. If you're not authenticated, return a status code result of 401. This means that you're not authenticated, and then it just sort of shortcuts the code that you're running. So what if we were to layer in another cross-cutting concern, like say, we want to time how long our operation takes? And this business logic here, this little bit, so we're kind of surrounding it with this timing code. Now, over time, especially if we have to do this in all of our HTTP endpoints or in many of our HTTP endpoints, this can get really, really cluttered. Let's look at it another way. Let's say these green dots are our HTTP endpoints. These are our controller methods. Now, let's say we've got a cross-cutting concern that touches every single area of our application, like say authentication. And so this is that red coating around those little green dots. Now, let's also say we've got something like transaction management and then some other thing. And then let's say for this little group, we've got one other concern. Like let's say this particular group, we have to do some authorization checking. And then for this other group, we've got to do some other things like say, we've got a particular way that we have to manage those transactions that has to be exactly the same for these groups. What you're noticing here is that the green part, the part that was our business logic, the reason for being for each and every one of those little controller methods is getting squeezed smaller and smaller and smaller because it's getting buried under layer upon layer upon layer upon layer of cross-cutting concern. What I like to call jawbreaker code. It's where these cross-cutting concerns are generating so much noise and just sort of wrapping around your code so much that the value is getting lost. If you've never seen one of these giant jawbreakers or busted it apart with a hammer, this is what it looks like. There was a candy shop that I used to go to when I was like 8, 9 years old, and they had these huge jawbreakers. And I remember this because they had a thing where some of the jawbreakers, it was like 1 out of every 20 or something, they had this gummy cinnamon center. And if you got one and you showed them that it had this center, they'd give you a free one. So as an 8, 9-year-old kid, I was all kinds of excited about getting free candy. And every time I get a jawbreaker, I'd be in such a hurry to find out, do I get free stuff? That was the only thing that I was concerned about. And the value, the thing that was in the very middle, the thing that was actually going to get me free stuff was the only thing I was concerned about. And the rest was just sort of like, this is in the way of me getting free stuff. So this is why we've got to be really cautious about using copy paste for dealing with cross-cutting concerns. One, you've got this jawbreaker code. You've got piles and piles and piles of cross-cutting concerns that are hiding what's the reason for this controller method to exist in the first place. Because if we're checking for authentication, we're opening a transaction, we're committing a transaction, we're wrapping it in a try-catch and doing some sort of protocol handling stuff, if that stuff is exactly the same or it's incredibly similar from one method to the next, to the next, to the next, the actual guts of what are we trying to do with this method sort of gets lost, it gets hidden. And then the other reason, and this is a really, really important reason why you don't want to rely on copy-paste for cross-cutting concerns, is because it gets hard to change. So let's say the way you're doing authentication changes, the way you're doing transaction management needs to change. You need to be able to change it in one place instead of having to go to each individual method all the way across your app. If you've got dozens or hundreds of HTTP endpoints, that can be really, really tedious, and you run the risk of forgetting one. And now, congratulations, you've got a bug. This is miserable. So, what do good cross-cutting concern look like? What does good code that handles cross-cutting concerns look like? Well, number one, your logic changes in exactly one place. You don't want to have to change the exact same logic in dozens or hundreds of places. So if your authentication method changes, or if you need to log a little bit more information or log it a little bit differently, you change it in one place, not in dozens, definitely not in hundreds. If the scope of what some cross-cutting concern changes, so let's say it used to apply to every single endpoint, and now it needs to apply to every single endpoint except these three, you make those changes in one place more or less. Sometimes that kind of gets fuzzy depending on whether or not there's an easy way to sort of draw a boundary around these things, and if it's not sort of mix and match. And then good cross-cutting concerns are stackable. What does that mean? That means we should be able to address different kinds of cross-cutting concerns easily, adding them, removing them, reordering them at will, ad hoc, however we need to. They shouldn't need to interrelate with one another. They shouldn't conflict with one another. Now, as we get into looking at some code, we're going to look at 3 different sort of classifications of cross-cutting concerns in their scope. So the first one, everything. So if these green dots are our HTTP endpoints, we have a cross-cutting concern that applies to all of them. And we're going to look at different kinds of code that makes it easy or not so easy to do this kind of thing. Now, let's talk about everything in a group. So if we want to draw a box around these and we want to apply a cross-cutting concern just to these, we'll look at some techniques to be able to do that as well. And then also, we want to look at how well can we handle everything except a little handful here and there. We'll also look at some techniques for that. So these 3 classifications, everything, everything in a group, and everything except. Now, before we get into the code, I also want to just sort of make a caveat here. This is about how do we handle cross-cutting concerns as it relates to HTTP traffic. Cross-cutting concerns in general are something that you need application architecture to help you handle. This is particularly for HTTP-related stuff. What I'm about to show you in these demos is not a substitute for sound application architecture as you get farther and farther away from HTTP. So if you've got a library or something that you're building and you want to maybe potentially reuse it in a console app, in a Windows app, or a GUI app, or something like that, what I'm about to show you is not a substitute for the way that you might want to implement or create some framework to help you with cross-cutting concerns in a situation like that. This is just for web apps. Now, my pledge with these demos, number one, I'm not a believer in canned demos, and so everything that you're going to see, you get to play with the code later. There's no smoke and mirrors. There's no magic. This is real code that works on my machine. It will absolutely work on your machine if you use the same SDK. And then the second thing is that you will see tests for all of the code that you are about to see, and these tests all pass. It is important to know how to test your code because that helps protect you from unexpected changes when you have to modify your code and add new stuff. Now, in a web app, the basics of dealing with a web app is you have a request that comes in, you have some code, and then that code does stuff and it sends back a response. So dealing with a cross-cutting concern in a web app means we've got to intercept that request response cycle, and it's got to be extensible so we can add our own code. So the first way that we're going to look at how we do that is using something called middleware. So middleware sits as a layer in between that request response cycle and the rest of your server-side code. So let's take a look at what that looks like. Okay, font size check. Is this big enough? Fletch, I see you kind of...
Yeah, I'm just unmuting. And there is they say it needs to be bigger. There's a lag, obviously, from us and what you see on Twitch. So it took a second, but they said it needs to be a little bit bigger.
Okay. All right.
I'd go two more clicks.
Okay. All right. Okay. Let's do right there. Okay. So here's a pretty standard ASP.NET Core controller. It has a single action method called get, and it returns an OK response. Hey, this worked great. Now, I've got some other controllers. Go right here. Like this one right here. This not found controller. And by the way, I don't know where the setting is in JetBrains Writer to make every single tab the same font size, so this will be fun. Notice we're throwing this not found exception. Now, we might want to define exception classes like this for different HTTP status codes, or we might want to do something like, say, dealing with, like if you're using Entity Framework and you have a concurrency issue, if dealing with Entity Framework, I believe the name of the exception is DB concurrency exception or something like that. So the point I'm making here is that we have classes that may throw exceptions. Goodness gracious, this font size thing, killing me. So when one of your controller methods throws an exception, either inside of it or deep down, maybe deep in a business logic class somewhere, what happens? You get a 500, right? Internal server error. So if we're going to do the right thing and speak HTTP in the right way, we have different kinds of things that can go wrong, and those are supposed to mean different kinds of HTTP status codes. So let's take a look at what that looks like as a middleware. And again, apologies for having to constantly size up the font here. So a middleware is simply a class. It doesn't have like an interface or anything to it. It doesn't inherit from a base class, but it has two requirements. The first requirement is that it's got to have a constructor that accepts a request delegate. And then the second requirement is it's got to have a public method that returns task called invoke async, and it accepts an HTTP context. Now, if you notice, I've made this an async method, and I'm calling this request delegate on line 20 here. And what this means is do whatever's next in the request processing pipeline. So if you remember back to this illustration right here, this middleware sits in between the request response cycle and all of our other server-side code. So this is code that lives in a controller, or if you've got other middleware, third-party stuff, this is code that sits in between this request response cycle and all of that other stuff. And if you notice, we're wrapping it in a try-catch, and we're looking for specific exception types, and we're translating those to status codes. And this is really, 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 really helpful, because instead of having in our controller method a try-catch, in this code right here, and having that repeated across every single controller in our entire app, instead, we can write this code exactly once, and it works right everywhere. But how do you test it, you say? Well, it just so happens you test it like this. Let's just get rid of some of this. So if you notice, we're using this Microsoft ASP.NET Core MVC testing package, and that is exactly the same name as the NuGet package name. And the way this works is you create a web application factory, which is a generic class. You use the startup class from your web app, and then you can use this factory to create a client, and this is an HTTP client. So if you've ever used the HTTP client in C# code, this is how you would test your web app. And so what this does is it creates an instance of your web app in memory, runs it, and then you can issue HTTP requests to it. So, okay. So what this is checking is making sure that when we don't have an error, so if you remember this OK controller, this one's fine. It's checking to make sure that the HTTP status code is OK. Now, when we throw a not found exception, we're checking to make sure that it gets translated to a 404. And here we are, throws a non-found exception, translates it to 404. So we've got tests for all of these things. So we're just making sure that whenever a particular type of exception gets thrown in our controller, or deeper down, if you have deeper business logic that goes on, whenever a particular type of exception gets thrown, it gets translated to an HTTP status code. So that's middleware. Now, one of the things that I've seen in the past with middleware is the idea that this is magic code that somehow needs to always get called, and that is not true. And let me show you an example. So this is C# code, and that means a middleware can make decisions. You can use ifs. So for instance, if we have a magic path that means something, we might decide, we're not going to call that other server-side code. We're just going to bail out early. We're going to do something with the response and not even call the rest of the stuff. And then, let's see, I have a test for this too. There it is. So if you notice, when we call this, we get that status code of 418. Our response text contains all of the stuff that we put in there. And this next here doesn't get called, which means our controllers never get called. So let's talk about how this plays when we think about the relationship between these two things. Well, first off, here inside of startup, this is how you hook a middleware up to your request processing pipeline. So inside of your configure method in your startup class, call use middleware. And if you notice, I've got two middleware, this Bobby Hill middleware and this exception translation middleware. Now, the order that middleware are declared in is important because in effect, it's kind of like they nest inside of one another. So back to this illustration, so you'd have a stack of middleware, one after the other, after the other, after the other, until you finally get to your controllers or what have you beyond the middleware. So for instance, you look back here, this is all the default stuff. So here, this is where using a middleware under the hood, it connects the MVC framework to your request processing pipeline. So middleware, as far as dealing with cross-cutting concerns, does a great job of dealing with that case of everything. We want a cross-cutting concern like translating exceptions to status codes. Does a great job of that. Now, if you want to do everything in a group, middleware is kind of hard to do with. If you want to do everything except this particular endpoint, that particular endpoint, you can do it, but it's kind of tedious because it's hard to draw the relationship between, say, a specific controller method and that middleware. So that's going to be a little tougher. You can mix and match middleware however you'd like to, just like we saw here. So if we wanted to switch the order of them, if we wanted to bring in a third-party middleware, something like that, totally easy to do. So I'm going to pause here. Fletch, do we have any questions on the stream?
No, nothing coming through yet. The question that came through was, are you going to talk about middleware as like right before you start talking about middleware? So I mean, that's perfect.
Awesome. All right, cool. So now let's talk about controller-based classes. So if you're in an MVC app, you have these things called controllers, and they all inherit from the controller class or from the controller-based class. So let's talk about what these can do for you. Close all of those tabs. All right. So what we have here are a bunch of controllers, and I'm really sorry about the font size here. Let's see. Is there a way to biggen this? So under our controllers folder, we've got fruits, and so we've got apple controller and grape and strawberry. And then under this proteins folder, we've got egg, we've got walnut, and then under veggies, we've got celery and tomato. Now, why am I doing this? Because we're going to talk about how we can use a base class to cover the case of we want everything in a group handled the same way. So if you notice this apple controller here, it inherits from this fruit controller base class. So let's go take a look at that. This on action execution async. I've never actually had to say that out loud before. That's hard. We're messing with the response by adding a header here, and then calling the base class on action execution async context next. Now, if you look closely at this, this is not that different from our middleware code that we just saw a little while ago. We're intercepting the request response cycle and fiddling with the request or the response, and then passing off control to whatever's next in the pipeline. Now, when it comes to tests, let's take a look at that. So, same kind of test here. So we're checking to make sure that when we get apple, it contains this fruit salad header. So the whole idea behind this is that we want to make sure that when we call a particular endpoint, does it have this X dash fruit salad compatible header. So apple should have that header. Egg should not, because you don't put eggs in fruit salad. Now, before we get into some of this other stuff, here's something that's really, really handy, especially if you need to enforce all of these things in a particular group need to have this same cross-cutting behavior. If you use a base class, you can get some help from reflection here. So let's say you can organize all of the controllers that need to be in a particular group that all need to have the same behavior, organize them into a namespace, filter by that namespace, and then make sure that they all have the same base class. Then let me show you, and let me get my tests up and running here. All right, so once again, the font size. Let's give me a thumbs up if the font size is okay. Do one more. Okay. All right. I'm going to run .NET watch test, and so what that's going to do is it's going to rerun my test anytime I change a file. All right, we're building. We're testing. Okay, so all of our tests passed. Now, watch this. So this test right here is going to tell me if for everything in this fruit namespace, so controller base class web controllers fruits. So I'm going to come down here to this grape controller, and I'm going to change this to just controller, but doesn't have that base class that it was supposed to. Now let's go back and look at our tests. Aha! Expected non-compliant classes to be empty, but found grape controller, this one that we just fiddled with. So this is a great technique that you can use to assert that all of the controllers in a particular namespace have the same base class, and by extension, that means, oh, all of these controllers have the same cross-cutting concern behavior. Now, as far as controller base classes go, so we got to look at some pros cons here. So controller base classes, if you want to cover everything in your app, you can do it kind of. I mean, you can use the same technique if you want to in your test to make sure that everything inherits from the same controller base class. Sure. Everything in a group, this is a great technique. Everything except you can maybe kind of sort of force it, but it's going to be painful. And this is the kicker. If you're using a controller base class to insert cross-cutting concern type behavior, you can't mix and match this kind of cross-cutting concern and that kind of cross-cutting concern and this one and that one, because C# is a single inheritance language. You can only inherit from one base class at a time. So you really can't mix and match behaviors for cross-cutting concerns using controller base classes. So we need a better technique. That's action filters. So an action filter is a C# attribute that you can decorate on a particular controller method or on a controller class, or you can actually register an action filter globally in your startup class like this. So let's go take a look at an action filter. First off, let's go look at walnuts. I don't know about y'all, but sometimes fruit salads are pretty nice if they have walnuts in them. So here's this walnut controller, and if you notice, I've got this fruit salad attribute on this walnut controller. So let's go take a look at this fruit salad attribute. So if you've never written a C# attribute before, this is what it looks like. It inherits from attribute, and it has this interface action filter. Surprise, surprise. This is how you do an action filter. There's also an async version of action filter if you need to do asynchronous stuff. So action filter has two methods: onAction executing, which is the one that the framework calls prior to control getting passed to your controller, and then onAction executed, which gets called after your controller's code has executed. So here, I'm doing the same thing that I did earlier. I'm just tacking in a header. And let's go, where are my tests? If you notice, we've got a test for walnut here. Also celery. I don't know if I like celery and fruit salad. This is actually kind of nice. Call me crazy. But here, celery controller, again, here's this fruit salad attribute. So here's an easy way to say this specific class or this specific method needs this specific behavior. So this is a great way to do mix and match. Now, let's take a look at a little bit more interesting of an example. So here we are with kind of more of an e-commerce sort of thing. So let's start with catalog controller. Okay. So we're going to search the catalog. We might get some item details about a particular item in the catalog in an e-commerce setting. So this is something that we want anybody to do. So if you notice, I've got this allow anonymous attribute here. Now I'm not going to show you the code quite yet, but I am going to show you the tests real quick. So if you notice, catalog search, catalog item details. We want to make sure that I can call these and we get the right response. So we get an okay response. And then for these, cart get, cart add thing, inventory, we want to make sure that these require authentication. So we get these and we're getting an unauthorized. So this is a 401. 401 means you're not logged in. You're going to have to log in before we can figure out whether or not you're allowed to do this. Now, then we've got two categories in our web app of authorization. One is you're a customer or you're an admin. So for all of these routes here, we want to allow customers. So we're adding a header here. By the way, this is terrible, 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 terrible security. Do not replicate this in production apps. Never, never, ever, because this is terrible. We're making sure that these routes are allowed for this basically as long as you're logged in. These routes, on the other hand, you have to be set as an admin in order for that to work. Okay, so how does this work in actuality? And this is something that's really, really important because sometimes you need to have interplay between different action filters. So let's take a look at our authorize attribute. So again, with the warning, this is horribly insecure, not suitable for real security. So we have this authorize attribute. This works really similar to the built-in authorize attribute that's in the framework, but I wanted to unpack this for you a little bit because it will help you be more effective with action filters. So if you notice here, in our configure services in startup, we're adding this authorize attribute. So what this is called a global action filter. This means that this action filter gets applied to every single controller method. Now, what this does not mean, and this is important, this does not mean that it gets applied to every single request or response in your web app, because some requests and responses never get to controllers because there may be middleware ahead of time that's intercepting it, like our Bobby Hill middleware earlier, where it says, no, we're going to handle this completely different, and we're not even going to pass control along down the pipeline. So bear in mind, there's a big difference between a global action filter and the scope that it applies to and a middleware. So here's our authorize attribute. Again, action filter. So on action executing, we have this action executing context, and it has this filters collection. So this is all of the action filters that apply to a given request response context. So if we've got 17 action filters all stacked up on top of a class or a method, they'll all be in this collection. So first off, we're going to check and see if this allow anonymous attribute is in there somewhere. If it is, we're going to say, yep, everything's good. Then we're going to go look for that custom header. We're going to look to see if that header says whether or not we're an admin. And we're also going to check and see if that header has any values at all. That's how we know whether or not they're logged in. So if we allow customer, That's whether or not this allow customer attribute is present. So let's take a look at an example of that. So on our cart, okay. So for our cart, we of course want to allow customers to do stuff with their own cart, but we don't want to allow customers to do things with, say, like checking inventory levels, restocking inventory, that sort of thing. Now, we do want to be able to for a customer to say, when I put stuff in my cart, is there stock? Should I actually check out, or should I pick something else, or maybe not finish this order? So if you notice, we've got the allow customer attribute just on this one method. So we allow anonymous, everything's okay. If we're authenticated, we're an admin, or if it allows customer, we can bail out. Otherwise, we're going to return the status code result of 401. Now, this is important here in an action filter. Whenever you do .result in an action filter and you set it to some kind of result, it's going to short circuit the request processing for that controller method. So if you set a result, your controller method's never going to get called. I'm going to say this again. If you set a result in an action filter, your controller method will never get called. This is probably a good thing, but it may surprise you if you're not expecting it. Now, action filters are great if, well, and actually I mislabeled this. This should have been an because like I said earlier, action filters, they cover everything if it eventually lands in a controller. If it won't land in a controller due to maybe a middleware or something like that, you've got a custom library that's doing some GraphQL, which doesn't use controllers, whatever. Action filters are probably not going to be the thing that you want. Everything in a group, again, it depends on how you want to do that. You can do some validation with reflection to check on that. Everything except if you want to mix and match, like everything in this controller except for this one little method needs to be handled the same way. Action filters are great for that. If you want to mix and match lots of different kinds, you want third-party filters, that sort of thing, they're awesome. Now, if you want to play the home game, and I would strongly encourage you to do this, and Fletch, if you wouldn't mind tossing this into the Twitch channel as well, all of the code that you've just seen is here on GitHub. All of the tests run, they pass. I would strongly encourage you to play with it. Go take the attributes off in places, watch the tests fail. Use .NET watch run. So there are three sets of projects. There's a web project and a test project. And just play around with it. This is a great opportunity for you to learn how to do this. So because it's October, I want to pause for questions. And I'm gonna make this go away now because it's gonna really get annoying.
That's awesome. All right. Yeah, that's awesome talk. I went ahead and posted that inside of the Twitch, and I've got my Slack closed right now so that alerts aren't going, the sounds aren't going into the thing. So I'll post it in there. Got some hoorays and hurrahs in the chat, but it doesn't look like any questions. I'm going to go ahead and post the link to this meet so people can join in here in a little bit, but let's give people a second, see if they want to ask anything on the live stream. So I have a question about the allow anonymous thing. I guess I'll throw that out there.
Fire away.
Actually, let's let Sean. Should I continue to use comments in code that says, oh God, I should have read it before I said it, because Floyd said so. So yeah, put your comments in your code that says because Floyd said so in there. That's
only if you've got a passing test that you've seen fail. Failing test, you add the comment, the test passes, totally good.
Okay, does the order of filters on a controller matter?
It can matter, but if it does, that's scary town. So be cautious. If the order matters, that can be quite the headache.
Yeah, I think so. Temporal coupling will hurt you every time. Does it change? Okay, so I think you're saying like in middleware, as you're registering the middleware in your startup.cs, the order that you register in is the order that the middleware will hit. Is that correct?
Yes, and bear in mind, it's intercepting the request response cycle. So if you've got middlewares 1, 2, and 3, and you specify them in that order, the way that's going to wind up happening is middleware 1 sees the request and then calls next, and then middleware 2 sees the request and then calls next, and then middleware 3 sees the request and then calls next, and then control gets passed back to middleware 3, and then back to 2, and then back to 1. So you got to think about it sort of like as it's nesting. So middleware 1 is the outermost layer, and then middleware 2 is the middle one, and then middleware 3 is the innermost layer of middleware.
Let me add to their question. Attributes. Does it matter what order you put the attributes in on a method?
That is technically not defined according to the C# spec, if I remember correctly. However, if you inherit from a certain base class, there is a or is it a base class or is it an interface? I can't remember off the top of my head. You can actually specifically specify what order. So you can put a number on your filter attributes and say, I want this one to run first, and I want this one to run second, and I want this one to run third. I would strongly recommend against doing that because that's just craziness. And it is the way of pain. If you have cross-cutting concerns like that need to run in a particular order, you're probably better off making that order explicit by putting both things into a single filter.
Nice. Yeah, I like that. Also, Sean now says, and he runs to go remove his filter ordering. That's a good idea, Sean. It's just the way that you talk whenever you say those words in the order that you just said them in when you were just talking. That's what we call a code smell. If you agree with that, yeah, I see it. You're doing it. It can be done. It works, but maybe it shouldn't be done. I like that.
Yep. And again, if you're making code changes and you don't have tests to back up those code changes, that's probably bad. The best case scenario when you make code changes in the absence of good tests is that you didn't break anything. That's the best thing that can happen.
All right. You got any closing words, or I think you think we're happy to move on?
Don't copy paste cross-cutting concerns. That is absolutely the way of pain. I can't tell you how many dozens upon dozens upon dozens of hours I have just thrown away where the same code has been copied and pasted over and over again. And then this is the fun part. I've never been in a situation where I've had to repair a code base like this where I haven't found subtle inconsistencies that hid bugs.
Do you have this is just another question for me. Do you have a rule of 3 or anything like that? Like, is it a cross-cutting concern if you have it in one, but you're expected to get it to be in others, or should you wait until you have 3, or is 2 okay? Like, do you have any thoughts on that?
Generally, I kind of go by gut feel. If this feels repetitious, let's find a way to deal with it once. Rule of 3 is good. There are always exceptions. Sometimes you've got similar code, but it's going to be more effort to consolidate that similar code than just to let it feel slightly repetitious. So I'm not a hard and fast rules kind of person, despite how opinionated I am about certain rules.
All right. Okay, cool. I'm going to go ahead and post this link then, and people can join in, and I'll stop the stream. Let me go ahead and post the link first so that people on the stream will be able to see it. Go ahead and jump in, and we look forward to talking to anyone who joins, and Floyd will stick around for a little bit, and we'll see what happens. So thank you, Floyd, and thanks to Techlahoma for hosting this, and we'll talk to everyone later. See ya.